Bonjour and welcome. This is Wahsa Distance Education Center's radio Zoom classes, and we are doing MBF3C grade 11 college math today. I am Bronwyn Slate. Making sure that everyone knows how to participate live if they want to, you can call the Wahsa studio 1-800-465-7144 or 737-4017 to ask questions and engage with me. You can listen on the radio at 91.9 FM or through the television at Bell Express View channel 972. You can also always join me through our Zoom link, which is available through me, your teacher, and also your DEC. Our schedule is, our class is Monday through Thursday from 11 till 12 in the morning, and we are now on week of our 9-week class. A reminder of what work to submit for marking. The support questions in your booklets, the ones marked with the pencil icon, are not for marking, they're just practice. You decide which ones and how many of them you're going to do depending on your needs. If you understand a concept, feel free to skip. If you need more practice, let me know and I will find you more practice. The answers are in the back of your booklet, so please check your work to make sure you're on the right track. However, there have been some mistakes found, so if you are concerned or you're confused, check with me and I will let you know if there's any corrections that can be made. The key questions, the ones marked with a key icon, are the ones that I will grade. So please do all of the key questions and show all of your work, all of your steps, all of your thinking, so I can give you credit for all of your understanding and you won't lose marks for making one error, but understanding other parts. So make sure you give me all of your work. How to submit your work for marking. There are 3 methods. The first method is to scan and send your work in electronically. You can scan your work through the iPhone's Notes app on your smartphone or through the Android Google Drive app. Then you can email it to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can also Facebook message your work through to me at bslatewahsa. If you need help scanning your work, let me know and I will help you. You can also drop it off into Lookout. We have an outdoor mailbox at 74 Front Street at the side entrance. We're the big red building next to the post office, and there's a small white mailbox next to our side entrance. We're currently closed due to COVID to the public, so if you drop it there, it may take a few days to get to me, but I will get it and get it back to you as soon as possible. The third method is to hand your work into DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax 1-800-463-7852. Always, if you have questions or concerns, please contact me. Email is the best way to get a hold of me. My email address is bronwyn.slate, spelled BRONWYN.SLATE@nnec.on.ca. Facebook is also a great way to get a hold of me. My Facebook name for work is bslatewahsa. You can call the office and leave a message for me at the front desk. The number is 807-737-1488 or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m. And I'll get back to you as soon as I can. Connecting with me through social media, here's an image of my Facebook profile so you can find the right me. You can also subscribe to my YouTube channel. All of our radio Zoom classes are posted shortly after airing. And I also have other videos that explain common errors and confusing concepts. So it's a great way to, a great resource to access if you're unable to get directly in contact with me. It's a very visual subject. And so being able to connect either through the Zoom classes live or watching the replays on YouTube, I strongly encourage. it's really, really hard to just listen and understand everything that's going on. Being able to see the examples and see the connections is really, really important. So trying to connect through the video, I strongly encourage. All right, we are in week 2. Today is day 5 of our course, and we are looking at lesson 3 today, which is solving and graphing quadratic functions. So our learning goals for this lesson is that at the end, I hope you can say, I will be able to solve quadratic equations by factoring and finding the zeros, as well as I will recognize the zeros of a quadratic equation from the graph. Okay, if that doesn't mean anything to you yet, that's our goal by the end of this lesson. Knowing that you've met the goal, the learning goals, because you can say, I can identify the x-intercepts on a graphed parabola. 2, I can explain why solving quadratics means y equals 0. And 3, I can use algebra to factor and figure out what values of x result in a y equaling 0. Again, this doesn't necessarily mean a lot to you right now. That's all right. This is what we're working through today. All right, let's do some brain activation and let's do some mental math to get going. Many of us experienced mad minutes to do arithmetic when we were growing up, and they were painful and stressful and didn't help us learn any strategies. Even though I have a degree in mathematics, I definitely have times in my life said that I'm not good at mental math because I wasn't ever taught any skills. I just felt like I was expected to do the algorithm in my head, and I wasn't good at that. So instead of doing that, we are going to be looking at strategies to get our brains working so that we can be comfortable with doing arithmetic with numbers. So today's question is 30 take away 19. Subtraction is not very many people's favorite things to do, so having different strategies is really, really useful. So when I look at this question, 30 take away 19, I noticed that 19 isn't a super friendly number, but it's really, really close to a number that is a fairly friendly number. So if I just adjust my 19 and I think, okay, instead I think of 30 take away 20, well, that equals 10. That's fairly manageable for me to do. But if I want to do 30 take away 19, I need to take away one more than if I just take away 20. So that means that I'm going to be left with, actually, I'm going to be left with 11. The difference between the two is 11 because it's one more than if I were just to take away 20. So sometimes we can adjust one of our numbers to make it a little bit easier to subtract, and then we can accommodate the adjustment that we made. Okay. Mine's on engaging our prior learning, remembering what we have done before. So looking at this question, we have xy equals 0. So thinking about that we have two numbers multiplied to each other to equal 0. What values of x or y would make this true? Thinking about that, what this means is that if we think about it, that any number of groups of 0 is 0. So we could have 1,000,000 groups of 0, 1,000,000 times 0, and we still would have 0. We still wouldn't have anything. Or we could think that if we have 0 groups of 1,000,000, we still have 0. We don't have 1,000,000 because we don't have any groups of that. So either way, one of our numbers needs to be 0 in order for our product, in order for our answer to be 0. Doesn't matter which one, but if one of them is 0, that means that our whole equation is going to be 0. So looking at another example, if I have x minus 2 times x equals 0, what values of x would make this true? So if we have a number, take away 2 times a number, and that all equals 0, how could we make, what values of x make that true? So first, we know that if I multiply anything by 0, that's going to result in 0. So this part, if we look at this, just this x could be 0, and that would make this whole equation 0. But I also know that if my other part, x minus 2, if that part equals 0 altogether, then my whole equation is going to equal 0. So x minus 2 is equals to 0 when x equals 2, because 2 take away 2 equals 0. So that might be kind of confusing. So let's check to make sure that this makes sense. So if I substitute in 0 into my equation, so I have, so for the example, x equals 0. If I have 0 take away 2 times 0, that is equal to negative 2, because 0 take away 2 is negative 2 times 0, and negative 2 times 0 is going to be 0. Okay, yep, that works. Now if x equals 2, what happens? So if I have 2, take away 2 times 2, because I'm replacing every x with a 2, then I'm going to have 0 times 2. Well, 0 times 2 is equal to 0. So that makes sense. So that's one way. So that tells us that these two options of x make x minus 2 times x equal to 0. Okay, next example. Now we have x minus 2 all times x plus 3, and that equals 0. So we are wondering what values of x would make this true. So the same thing applies, that either our x minus 2 has to be 0, or x, just change colors, x plus 3 has to equal 0 in order for this whole thing to equal 0. So let's figure out what our options for actual x are. So our first one, we said that x minus 2 could be equal to 0. Well, x minus 2, the only way that that is going to equal 0 is if x equals positive 2. So that's one of our options. And then x plus 3, it was our other part of our equation. That's our other option that has to equal 0. So figuring out, okay, well, how do I get, if it's not going to be plus 3, because if 3 plus 3 is going to be 6. So that's not how we figure out. So how do we figure out what our x is going to be in this situation? You can do algebra in terms of thinking about isolating for x. So if we want to get x by itself, now we have x plus 3. So if we're going to subtract 3 to get rid of that constant, if we do it to one side, we're going to do it to the other side. And so that means that we have x plus 3 minus 3 equals 0 minus 3. And so then our plus 3 minus 3 cancel each other out. So we have x equals to negative 3. So you can either think of it logically, what's going on, or you can go through the algebra to isolate for your variable. So in this example, the values of x that would make x minus 2 times x plus 3 equal to 0, x is either 2 or x equals to 3. And that's how either of those options would make our whole equation 0. Let's check it again just to make sure that we understand that this actually is working. So we can always do that. We can always check. So if we're checking and we say, so our example x, our solution x equals 2. So that means that for every time we see x, we're going to put in 2. So we have 2 take away 2 times 2 plus 3. Well, that equals 0. 2 take away 2 is 0. 2 plus 3 equals 5. 0 times 5 is 0, right? That option worked. So if x equals negative 3, does that work? So every time we see an x, we substitute it with negative 3. So negative 3 minus 2 times negative 3 plus 3. So negative 3 take away 2 is negative 5 times negative 3 plus 3 is 0. -5 times 0 equals 0. So that also works. So those are both those values make our full equation equal to 0, which is what we wanted to do. Okay. So that's one thing that we need to remember is that two numbers times each other, the only way that they're going to end up being 0 is if one of those two numbers equals 0. There's no other way to get our product to be 0. Now, the other thing that we need to remember are what are our intercepts. So what does that mean when we're talking in math? So I like to bring up this example of football. I'm not a sports person, but I know that in football, and actually probably other sports as well, you can intercept the ball. So you can cut in front of that line, right? So what intercepts are when your line, your function, cuts your axes, either your y-axis or your x-axis. So here we have an example of linear, of a straight line, and of a parabola. And we can see that our y-intercepts in both of these examples are when our graph crosses the y-axis. So our y-axis is our vertical axis. And then our x-intercepts are when our line or our parabola or curve cross our x-axis, our horizontal axis. So those are our intercepts when our number or when our function crosses our axes. So that's important to remember for this. Okay, so active learning, what are we doing that is new today? As always, the question that I'm most commonly asked is, when will I use this in real life? And you might not be calculating intercepts or axes in real life, but in real life, you will be making educated predictions, and that's the skill that we're building through this course. That's one of the elements that we're building. So the first thing we're going to be doing today is we're going to be looking at recognizing the zeros on our graph and what that means. This is on page 22 of your IL book. So if you're following along, that's where we can go. The example that we have is y equals 0.25x squared minus 2.5x minus 6. So we're trying to figure out what does it mean to have zeros on our graph for this function. So the first thing we're going to do is we're going to graph our function. You can use a graphing calculator or an online thing to graph, or you can also make a table of values and plug in all your values into your function and then graph those points. So putting in -4 into our x, so then putting that in for every value of x that we see and calculating out our value, we're going to get 8. And then we plot -4 to 8. -2, we put in -2 for our x, we end up with 0. We put in 0 for our x, we get -6, and we continue putting in values for our x and finding the resulting y values. You can choose whatever values of x that you want. Over time, you'll find out what are going to be convenient ones, what are going to be ones that make the most sense for the question. Here you can see that I went up by 2s. That made more sense to get my full curve for what I wanted to see. So then for graphing our points, we then connect them with a curve and we can see the shape of our parabola. So we've graphed our parabola and now we need to figure out what are the zeros? What does that mean? So the zeros by definition are the points that are where our parabola crosses our x-intercept. And what that means is what values of x make it so that our y is 0. That's why they're called the zeros. So for our parabola, when will our x values make our y be 0? So for this example, the zeros of y equals 0.25x squared minus 2.5x minus 6. The zeros are x equals -2, my bad, and x equals 12. Those are the 2 points that if we put those values of x into our equation, our y value is going to be equal to 0. Okay, so let's do a practice question of identifying the zeros of a quadratic function. So looking at this graph. If you're just listening to it, there's a graph. We're trying to find the zero values. So our zero values happen when our parabola crosses our x-axis. Our x-axis is our horizontal axis. And so that happens here at -4 and at +1. So for this example, our zeros are when x equals -4 and +1. Next example, we have another parabola. Again, we're looking for how to identify where our parabola crosses our x-axis, our horizontal axis. So we look at our graph and we see, okay, here that happens at 1, 2. So x equals 2 is one of our zeros, and our other zero is here when x equals 6. Third example, our parabola, this time we can look and it sees our parabola goes through our origin. So x equals 0 is one of our zeros, and x equals 7 is another one of our zeros. This pattern is starting to make me wonder, do we always have 2 zeros? That seems to be what's going on with parabolas. We often have 2, but looking at this fourth example, we can see that x here, the only time that our parabola touches our x-axis is here when x equals 5. So in this case, we only have 1 0. We only have 1 in x-intercept. Fifth example, here our parabola is opening down instead of up, but still our parabola crosses our x-axis twice. So when we have x equals -2 is one of our zeros, and x equals -3 is our other zero. And finally, our sixth example, here this parabola is opening up, but it doesn't cross our x-axis. And so in this example, we have no zeros. And that happens sometimes, is that we don't have any, our parabola doesn't cross our x-axis. That means we have no zeros. We have nothing. It never is it that this parabola's function is going to equal to 0. Okay, so that's how we identify our zeros when we're looking at a graph, is that we look at the graph and we find where does our parabola cross our x-axis. Okay, but then how do we find our zeros without graphing? So this is on page 20 of your IL book. So in order to find your zeros without graphing, this is called solving quadratic equations with factoring. Factoring that we were doing in the last lessons in lesson 2 is coming to play at this point. So 2 things to remember. Solving a quadratic equation means finding the x values that make y equal to 0, right? Finding when our parabola crosses the x-axis. And factoring means finding the terms that multiply to be our product. So thinking back of when we were doing it in lesson 2, finding those, taking our trinomial and breaking it up into 2 binomials generally is what we were doing. So for example, y equals x squared plus 3x minus 10. So if we're going to be solving this equation with factoring, step 1, solving the equation, we're trying to find when this equation, when this parabola crosses the x-axis. So we're trying to find those, maybe 2, maybe 1, maybe 0. Those are our options for a parabola. So what we need to do is we set our equation equal to 0, because thinking back to what we just did, this means that we're looking for the x values when y equals 0. So what we do with our equation is we take our y and we set it equal to 0. So then step 2, factoring means finding the terms that multiply to be our product. So factoring, remember we're saying that either when we have something equal to 0, either the one number or the second number has to be 0 in order for the whole thing to be 0. So that means that we need to factor in order to break that up into two numbers and figure out what the x could be for that. So I have, for this example, I've just done the factoring. So we now have, for step 2, we now have 0 equals x plus 5 times x minus 2. In order to get that x plus 5 to x minus 2, that is factoring that we did in lesson 2. So if you're not sure what we just did here, then you need to go back to lesson 2. And there are videos posted on YouTube. I'll link them in the show notes. So you need to be able to do that before you can do this. So then once you've done that, you've set your equation equal to 0, you've factored to get your two binomials. Now we need to figure out what x's make this whole equation equal to 0. And this is a new part that we're just doing. So either x plus 5 equals 0 or x minus 2 equals 0, right? One of these two things has to equal 0 in order for the whole thing to equal 0. So x equals minus 5 or x equals positive 2 in order to make this whole thing equal to 0. Again, you could check by putting them into your original function and see what happens. You should get 0. So then wondering, does the graph give us the same answer? It's good to just make sure that the same thing's happening. So if we are to graph this function, then we can see that yes, indeed, our parabola goes through our x-axis twice at -5 and at +2, which is what we were able to find with doing our algebra and factoring. I've again used Desmos to graph this. I'll link that in the show notes as well as a tool for you to help you graph if you want to check your work. So there are two X-intercepts and they matched what we found algebraically. Okay, so sometimes our quadratics don't look familiar or are not set up in ways that we expected. So what we need to be able to figure out what we do in those situations, because math is always about being able to apply the same thing in multiple ways. So if we have this first example, x squared plus 8x equals minus 12. So here we don't have it equal to y. Not sure what happened. We don't have it equal to y. And so how do we get it equal to y? More importantly, how do we get it equal to 0? So what we can do here is that we can rearrange our equation such that we want it set to equal to 0 because that's what our first step is, right? So x squared plus 8x, in order to get the equal side to be 0, -12, we have to add 12. So if we add 12 to one side, we're going to add 12 to the other side to keep our equation balanced. And so then we have x squared plus 8x plus 12 equals 0. And now that looks the same. Now we can factor our trinomial and set it equal to 0, and then figure out what values of x could make that be true. So that's one way, is that you might have your constant or one of your terms on one side and your other terms on the other side of your equation, and you want to rearrange it such that all of your terms are on one side of the equation and you have 0 on the other side. Okay, second example. Here we have x cubed plus 5x squared plus 4x equals 0. Well, here we don't have our parabola needs to be x squared, right? And here our degree is 3. We have a higher degree. But if we look and we have x in each of our terms, so we can factor x out of our equation. So if we factor x out of our equation, we have our expression, we have x squared plus 5x plus 4. So overall, we have x times x squared plus 5x plus 4 equals 0. And so now we can factor out, we just common factored. Before we were common factoring a number, but this time we common factored a variable, and that's fine. And now we can see if we can factor what we have inside in order to find our zeros. And then third, here we have 2x squared plus 6x plus 4 equals 0. Again, we want to always common factor first if we can. Here we have our coefficient of 2 on our x squared term. So we're going to factor out that 2. 2 times x squared plus 3x, because 3 times 2 equals 6x, plus 2, because 2 times 2 equals 4, equals 0. So you can factor out a number or a variable, and then you go on to factoring the inside to figure out what that's going to look like to find your zeros. So sometimes your equation is not going to look exactly like our first example, and you need to manipulate it a little bit in order to get it to be something that looks like what you can factor, what you're expecting. So just because the question doesn't look exactly like the examples, don't panic. Make sure that you check to see if you can common factor or if you can rearrange your equation such that it does end up looking like you expect it to. All right, so now is a good time to pause the video and look at some support questions. So on your IL booklet, page 21, questions 1 through 4, and page 23, questions 5 are, you should be able to do those now. Okay, so then putting all the pieces together, we're going to consolidate all of our learning. So what we've done in this lesson, we have solving quadratic equations with factoring. So that we remember there's those 2 steps. There's solving the quadratic equation means finding x values that make y equal to 0. So we're setting equations equal to 0. And then factoring means that we're finding the terms that multiply to be our product, because the 2, in order to find what equals to 0, if we have 2 numbers that multiply to each other, one of those has to be equal to 0. So that we also recognize the zeros on our graph. And the zeros on a graph are the x-intercepts. So the x-intercepts are where your parabola crosses your x-axis. Okay, so our success criteria. Our first one was that you can identify x-intercepts on a graph parabola. So hopefully you can do that now. And our other ones were, I can explain why solving quadratics means y equals 0. And I can factor and find the values of x that means y equals 0. So both you can explain why we need to do this, but also then you can also calculate, you can execute it so you can find what, you can actually find your zeros algebraically. Okay, so let's do some more practice questions. Just make sure that this makes sense. So identify the zeros for each quadratic function. So we have question 1, x squared minus 9x plus 18 equals 0. So already our equation is set to 0, so we don't need to do that part. That's already set up for this question. So we need to, that means step 1 is done. And we need to factor in order to figure out which values of x are going to make this whole thing equal to 0. So a reminder what we need to do for factoring. So for factoring, we remember that we are looking for 2 numbers. So we're going to have, and I'm not going to do it using algebra tiles, but you can use algebra tiles if you want to. But we know we're going to have 2 numbers. So we have 2 binomials. So I open my 2 sets of brackets, and this is going to be equal to 0, which is a little bit different than before. Before we didn't have an equal sign. We were just working with the expression, but now we're setting it equal to 0. So in order for x squared to happen, we know that we have to multiply x by x. So that goes in our first spot. Now we need to figure out what we're adding or subtracting to our x's in order to multiply this out. To do that, we need to think about what 2 numbers multiply to be 18. So to do that, we need to find our factor pairs. Again, if this is not familiar, go back to the previous videos and look at the lesson 2 work. So our factor pairs for 18 are going to be 1 and 18, and -1 and -18. then 2 and 9, -2 and -9, and then 3 and 6, -3 and -6. Hopefully finding your factor pairs is a little bit more comfortable after you've practiced through lesson 2. But again, the more times you do it, the more comfortable you're going to get to figure out your factor pairs. It's okay if you forget some. If your options don't work, then you can always come back and think about if there are more pairs. So now that we've found our factor pairs, we need to say, okay, well then what numbers add up to be the coefficient of our middle term, which is -9 in this example. So what set of our factor pairs adds up to be -9? Well, 1 plus 18 equals 19. That's not going to work. -1 plus -18 is -19. So that's not going to work. 2 plus 9 equals 11. So that's not going to work. -2 plus -9 equals -11. That's not what we want. 3 plus 6 equals 9, which is close, but it's positive. We want negative, so that doesn't work. So -3 plus -6 equals -9. So that is our set of that we want. So then we put those two numbers, -3 and -6, back into our binomials, and we have x minus 3 times x minus 6 equals 0 as our factored expression. So before, this would mean that we were done, we were happy, we were good to go. But now, because we're trying to find the zeros, we're not finished. Now we need to keep working. We need to continue on. So we factored, but we need to figure out what values of x work such that this whole thing is going to be equal to 0. So that means that either our first binomial needs to equal 0, or our second binomial needs to equal to 0. So we can say either x minus 3 equals 0, or x minus 6 equals 0. And this is why your sign matters, because x plus 3 and x minus 3 are going to give you different results. So x minus 3 equals 0, that only happens when x equals 3, and x minus 6 equals 0, that only happens when x equals 6. So our zeros when x equals 3 and 6. So let's check that, just because we haven't checked it with doing the full example. So, and it's always a good idea to check if you're feeling unsure, or to just as you're getting more comfortable. So to check this, we can say, okay, so we're going to check when x equals 3. And what we're going to actually do is we're going to set it into our original question, because maybe we made a mistake in our factoring. So we're going to set it back into our original question and see if x equals 3 makes this original question equal to 0. So we're going to use x squared minus 9x plus 18. So if x equals 3, every time we see an x, we're going to input a 3. So 3 squared minus 9 times 3 plus 18. So 3 squared is 9, minus 9 times 3 is -27, plus 18. So 9 minus 27 is -18, plus 18 equals 0. So x equals 3 works. Okay, so let's check x equals 6. Same thing, we're going to put it back in the original function to check, just in case we made a factoring mistake. So we're going to put it in x squared minus 9x plus 18. Every time we see an x, we're going to put 6. So we have 6 squared minus 9 times 6 plus 18. So then we have 6 squared is 36, minus 9 times 6 is 54, plus 18. 36 minus 54 is -18, plus 18 is 0. So there we go. So x equals 6 also works. These checks you can write out, or you could also just use a calculator and plug in your values of X to see if they end up being to 0, just to check your work, whatever works for you. Okay. We had another example here, and I've written all over it, so I'm going to erase my work. Okay, so example 2, b squared plus 5b equals 0. Okay, so we're set equal to 0, so then that step's already. So now we're going to factor. Remember, we're supposed to common factor first. I forgot to check that for the first question, but we're going to common factor first. So b is common to both these terms. So b, we're going to factor out, and then we have b times b is how we get b squared, plus 5 is how we get 5b equals to 0. So now we look, do we need to factor further? No, we have two numbers multiply each other. We don't have any squared terms or cube terms or anything like that. We just have b. So in this case, we don't have to do any factoring further. We've factored as much as we can. And we say, okay, either b equals 0 or b plus 5 equals 0. So b equals 0, we're done. And b plus 5, that only happens when b equals -5. So our zeros happen when b equals 0 or -5. Again, we could check it if we want to. We're not going to go through the time right now to do that. Okay, practice question 3. K squared plus 15k equals -56. Okay, this time this doesn't have it set equal to 0, so we need to force it to set equal to 0. So we're going to rearrange our equation to make it so that it equals 0. So in order to do that, we have k squared plus 15k. And on the other side, we have -56. So if we have -56, that means we want to add 56 in order to make that 0. If we do it on one side, we have to do it on the other side to keep it balanced. So we end up with k squared plus 15k plus 56 equals 0. And now we've rearranged it such that we have a trinomial on one side, or we have all of our terms on one side, and we have it equal to 0 on the other side. And so now we can factor to figure out what values of k are going to make this whole thing equal to 0. So we know that we're going to have our two binomials. We're going to have k at the first part of our binomials, because the only way to get k squared is to have k times k. But we need to figure out what two numbers times to be 56 to be 15. So 56, what two numbers times to be that? We need our factor pairs. 1 times 56, -1 times -56. Now you can continue. I'm going to jump to, because 56 is a fact that I know, and I know that that equals 7 times 8, and -7 times -8 work. You could see if there's other factor pairs, but you don't have to list all the factor pairs if you have an idea of what might work already, because 7 times 8 equals 56, and 7 plus 8 equals 15. So I know that my factor pairs are going to be +7 and +8. So you can go through all the steps if you need to, but if you have an idea, you can just skip to the ones that you need to know. You don't have to list all your factor pairs if you can look at the question and know right away what your pairs are going to be of your numbers. So then we factored it. We need to figure out what k equals in order for either of these sets to be 0. So k plus 7 has to equal 0, or k plus 8 has to equal 0. So k plus 7 only equals 0 when k equals 7. Sorry, -7. It's important. Your signs are so important. It's easy to mix them up. It's easy to drop one, as I just did, but then it's completely wrong. So you need to make sure that you keep your sign. So k, in order for k plus 8 to equal 0, k has to be -8. So our zeros happen when k equals -7 or -8. And that means that we could actually even graph from here. We could graph those intercepts and know that that's where our parabola is going to cross our axes. But we'll do more of that later. Okay, one more example like this. We're going to just clear our ink. Then we have t, so example 4, we have t squared equals 11t minus 28. Okay, so this time we don't have just our constant on the other side. We have our two term, we have x squared on one side and t squared on one side and 11t minus 28 on the other side. So we need to rearrange that such that we have all of our terms on one side. And we can do that. To do that, we can choose to either move our x squared over to the side with our other terms or other terms over to our side with our t squared. Sorry, I keep saying x squared, it's habit. But I want to have a positive t squared term. It's easiest in my life if I have a positive squared term. So if I move my t squared over to 11t minus 28, I'm going to end up with a negative t squared, and then I'm going to have to factor out -1. So instead of doing that, I'm going to move all of my terms over to be with my t squared. So t squared, in order to move my 11t, I'm going to subtract 11t. So if I do it on one side, I'm going to do it on the other side. And in order to cancel off my minus 28, I'm going to add 28. If I do it to one side, I do it to the other side. So I end up with t squared minus 11t plus 28 equals 11t, take away 11t is 0, negative 28 plus 28 is 0. So then that equals to 0. So now I have all of my terms on one side and 0 on the other side, which is what I wanted. Again, you could have rearranged it slightly differently and ended up with all of your signs would be opposite of this, and then you would need to factor out -1 because that's common to each of them. You want to have a positive squared term. Okay, so now we are ready to factor. We know we're going to have our two binomials because we don't have any common factoring. So we check that. Our coefficient of our t squared is 1, so we don't have any common factoring. And so now we have our two sets of binomials, bracket pairs, set equal to 0. And so then we have t in the first part of each of our brackets, because the only way we get t squared is by t times t. And then we need to figure out what two numbers multiply to be 28 and add to be -11. When I don't put a sign, I mean positive. You can get into the habit of putting a positive to make sure that you put the negatives. You do what works best for you. Okay, so factor pairs. I'm going to say what numbers multiply to be 28. So 1 and 28, -1 and -28, 2 and 14, -2 and -14, and 4 and 7, -4 and -7. Okay, so I'm looking for a -11. So instead of starting at the top that I know is probably not going to work at all because 1 plus 28 is not going to get me close to -11. I'm going to start at the bottom and say, okay, well, -4 plus -7 is equal to -11. So there we go. Those are the ones that I need. So again, you don't have to you go methodically in terms of what works for you. You can jump around as long as you have a system that works for you. You do what works best for you. So that means that -4 times -7 give me positive 28, and add it together give me -11. So they are our two terms. So we have t minus 4 times t minus 7, and we factored it. So now to find the zeros, it's easy to forget that you need to keep going. So it's important to remember that you need to answer the question that's asked. So we need to identify the zeros. That's what we need to do. So that means that t minus 4 equals 0, or t minus 7 equals 0. So t equals 4 and t equals 7 are our two options of what would make this equation 0. Again, you could check it by putting your answers back in at your values of t back into your equation, but we're not going to do that today If you're having struggles with that checking work, then please let me know and we can work through it together. Okay, so now we have a word problem. We have a few more minutes, so we're going to try to get into this a little bit. The height of a flare fired from the deck of a boat in distress can be modeled by h equals -16 squared plus 96 t plus 112, where h is the height of the flare above water and t is the time in seconds. When does the flare hit the water? Okay. So for this sort of question, I like to draw a general sketch, even if it's not perfect, just so that I know what's going on. So I'm on a boat and I'm shooting a flare up in the air, and it goes up in the air and then it comes down and hits the water. That's what we're saying is happening. And the question is asking, when does that happen? When does it hit the water? So we can see with my quick sketch of a parabola going up, of something going up in the air and coming down and hitting the water, that's when our x-axis. So that's telling us that it is happening at our zero. So we're finding our zeros. So h equals -16t squared plus 96t plus 112. Those look like awful numbers, but we want to remember that we can common factor first if we need to. So we can say, okay, let's common factor out -16. I'm going to use a calculator because I do not know what 96 divided by -16 is. So that is -6. So when I factor out -16 from 96, I get -6, because -6 times -16 equals positive 96. And then 112 divided by -16 gives me -7. So again, so I've common factored out that 16. That makes my numbers a lot more friendly. But then I also need to remember that, oh, I forgot that h, what we're looking for is our height to be 0. That's when our flare hits the water. So we set that equal to 0. Now it looks familiar in terms of what we were just doing. So now we say, okay, well, we need to factor t squared minus 6t minus 7. So what two numbers multiply to be -7 and add to be -6? Well, our factor pairs are going to be 1 and -7 and -1 and 7. 7's a prime number. And so then we have, okay, so 1 minus 7 is going to give us -6, opposed to -1 plus 7 is going to give us positive 6. So our factor pairs are 1 and -7. So we put that back into our binomials. So t plus 1 and t minus 7 are factored. So then we look in and we say, okay, well, one of these numbers have to equal to either t plus 1 has to equal 0 or t minus 7 has to equal to 0. This minus 16 that we factored out doesn't actually change things because we already factored it out, and it's not going to, no matter what we multiply, if one of these equals to 0, if we multiply it by -16, it's still going to be equal to 0. So that doesn't actually change anything. So t plus 1 equals 0 or t minus 7 equals 0. T plus 1 only happens when equals 0 only happens when t is -1. T minus 7 equals 0 when t equals 7. So now we need to think about what those numbers mean in the context of this question. So when does the flare hit the water? Well, does the flare hit the water at t equals -1? So when time is -1 seconds, well, that doesn't work. So we call that indemnifiable. Probably spelling it wrong, but it doesn't work because we can't have negative time. So t equals 7 has to be our time, because at 7 seconds is when our only option. Having a positive time is our only option. So then we say the flare, because we interpret what our questions are. The flare hits the water at 7 seconds. And there we go. Now we're done. All right. We don't have time for the last question, that last word problem, but thanks so much for joining me today. As always, get in contact with me through the various channels, and I look forward to seeing you at next lesson. Have a good day.